Hello and welcome to part 2 of the Cambrian explosion. We have been looking at this phylogeny of the animals. And now it's time to talk about what is the Cambrian explosion. So first of all, the Cambrian is a period in Earth history from about 540 million years ago to 480 million years ago. And at the beginning of this Cambrian period is when we see a sudden rise in the diversity of animal fossils. This figure has a lot of information in it, and honestly, it's kind of a lot to take in, so let me walk you through it a little bit at a time. So we've been looking at this tree, and this tree is the predicted evolutionary history of the animals. As all phylogenetic trees are, remember, it's just a prediction of the evolutionary history. And the ancestors of the animals are predicted to go back to, according to this tree, 780 million years ago, which was a long time ago. Long before the Cambrian period. So why do we talk about the Cambrian explosion? Well, that's because that's when we start seeing a huge rise in the diversity of the fossils. And that is what is being shown in this yellow shaded area. So you see in the legend, this is the number of classes represented by the fossils that were detected in the rocks of this age. So putting all this together, what this means is that we think the animals have been around for a very long time, back to almost 800 million years ago, but they didn't leave a large diversity of different kinds of fossils until the beginning of the Cambrian period. That's what this yellow curve is showing. This is why we call it the Cambrian explosion. So why is this? We think that all of these major animal phyla, you see all these branches of the animals that we see today go all the way back here, but they weren't leaving very many fossils, and the fossils that they did leave were all kind of boring. They all kind of looked the same. There wasn't very much diversity in those animal fossils before the Cambrian. So why is that? Well, in order to understand why these Cambrian fossils are so different, we have to think a little bit about what the animals were like during the period before the Cambrian. That's called the Ediacaran period. These are some of the animals that we think would have been abundant during the Ediacaran. First of all, they're in the ocean. Didn't have animals on land at this point. And what else do you notice about the animals in the Ediacaran? They're soft, right? They all have soft bodies. They are not going to leave very good fossils except in very specific fossilization conditions. Also, they're all kind of boring. Unless you happen to be a fan of Ediacaran fossils, these animals don't have the diversity. They don't represent the diversity of animals that we have today. So just to spell this out, the Ediacaran animals were mostly sessile. That means they were attached to the seafloor. As you can see in this image, these fan-like animals are attached to the seafloor and can't move around. The ones that are swimming are jelly-like animals that are swimming like jellies do. You don't see any fish in this picture. So no swimmers and also no burrowers. The animals in the mud, which are also shown in this image, are very slowly kind of crawling along the bottom, but you don't see anything actually digging a hole into the mud. And that turns out to be a big difference between the Ediacaran and the Cambrian. Ediacaran animals are mostly feeding on the microbial mats on the ocean floor. So before there were lots of animals burrowing into the seafloor, microbes were able to form really thick mats that would grow for centimeters above the seafloor. And we can see fossils of those. Today we call them stromatolites. We've talked about these before. As we said, the Ediacaran animals are mostly soft-bodied. There weren't really any shells at this point. That was a big innovation of the Cambrian. No other hard surfaces. And also, do you see any heads in this picture? Do you see any eyes? Do you see any mouths? Do you see any arms? Do you see any legs? No, the animal plans during the Ediacaran were quite simple. They don't have the complex sensory systems and mobility systems that we see today. These are the animals that suddenly appeared very quickly during what we call the Cambrian explosion. So you see organisms that are swimming, you see animals that are burrowing into the seafloor. As I just said, this was not happening during the Ediacaran. You see animals with heads, with eyes and mouths. They're swimming with things that kind of look like arms or fins. And you see animals that are feeding on each other. You have a complex ecosystem of predators and prey, which you do not have in the Ediacaran. Let's talk about each of these examples in a little bit more detail. So here again is showing some of those animals that we saw in the Ediacaran. Again, they're just living on the surface or even attached to the surface or crawling slowly along the surface. And in the Cambrian, we start seeing all these fossils of animals that can actually dig down into the sediments of the ocean. And you can actually see fossils of those in the Cambrian explosion. So here is a fossil of a worm that's digging down into the mud. Here are fossils of burrows. So these aren't necessarily animals themselves, but these are the burrows, the tunnels, and the mud that the animals left behind. And if you, like me, aren't exactly sure what this fossil is supposed to be showing, here's a nice artist's rendition of what it's showing, which is a series of tunnels. So this is an animal that was living in the subsurface and was making these series of tunnels, providing it access to the surface. That's what these fossils are actually showing, is a very active burrowing ecosystem. You see swimming animals for the first time in the Cambrian. You saw things like this, which is actually an ancestor of the vertebrates, or the chordates, which we'll talk about in a later lecture. But for now, just to note that you already had animals in the Cambrian that had notochords, which is the ancestor of the spinal column of animals today. And you had segmented muscle tissues, which is something that you do not have in the Ediacaran. So these are important anatomical features that you see in modern animals, and you see them for the first time in the fossils of the Cambrian explosion. In the Cambrian explosion, you see a huge diversity of shells. So hard-bodied shells that, first of all, fossilize really well. So that's one reason why they show up really well in the fossil record. And it's also an indication of a very active predator-prey ecosystem, because the reason why you make a shell is to protect yourself from other animals that want to eat you. The adaptations for predator protection became very complex and elaborate and ornate very quickly. You can see them already in the Cambrian explosion. So you have these weird mollusk or annelid type animals, and they not only have shells, but they have these scary looking spikes that are intended to keep predators away. Here is something that might be related to the modern day velvet worm. It also has these scary looking spikes that was almost certainly a form of predator protection. And to just list all of these things out in one slide for you, the Cambrian explosion is when life goes three-dimensional. You have burrowers, you have swimmers, you have predators and prey, you have shells and other adaptations to protect the prey from the predators, you have the first appearance of hard exoskeletons and spines, which also fossilize really well, so that's one reason that we know that they appeared at this time. You also have the first appearance of bilateral symmetry and body segmentation, which will be the topic of the next video, so stay tuned for that. You have the first appearance of heads, that is, things with complex sensory systems in the front of the animal, like eyes and mouths. And all this innovation led to this great diversification of animal anatomy and physiology that we see in the fossils of the Cambrian explosion. So here's your self-quiz for this part of the lecture. List at least 2 of the reasons for the lower diversity of the fossils in the Ediacaran compared to the Cambrian explosion. Think about that to yourself, and I'll see you in part 3.